Hello and welcome to this week 10 class traffic engineering. So it's 2 minutes to 7 p.m. So I'll wait for 5 more minutes and check if anyone joins, and then I'll get started with today's content from 7:05. So it's 7:05 already. So I'll get started with today's class. So we have only one person joining in so far. So hopefully more people will join in after some time. So welcome to this week 10 class on traffic engineering's TA session. So the topic of discussion of this week is traffic control and management. So as usual, I'll be solving some of the related problems to the assignment 10 that you'll find. And the content I felt was relatively easier compared to the other contents that we have seen in other weeks because there is no like maths involved, numericals, and all those things are not there. So probably it might be a shorter session as well if I'm done with solving all the problems or the questions that I intend to do. So yeah, I'll turn off my video and get started with this session. So I'll share my screen. So yeah, hopefully my screen is visible. So the overview or the outline of this week's content includes the introduction to traffic control and management. So specifically, there are, I think, four aspects that are looked at in this week's content. One is access management. Then it's the demand management. Next is bus priority treatments. Then there is emerging traffic management measures. I think parking is a discussion of next week, so we won't be going into the details of those. So these are the broad topics that have been covered in this week's lecture. So let's probably pick up some questions directly and maybe related to the contents of the this week. So access management might have some of the questions in the assignments. I'll check which are of those are present in the assignment and I'll can solve similar questions to that. So let me slide. This is so let's look at the first question. So I'll be giving you so state true or false. So it says traffic management solutions cost more than road expansion projects. So that's one. Next is let's let me give you another. Okay, let's solve this first, and then I'll give you another problem. So I think in the initial portion of the slides, you'll find that traffic management solution actually doesn't cost more than expansion projects. So it's more expensive if you want to build more roads and you want to expand your existing road network. So this statement will be false. Pretty straightforward. So next there is like again related to all the aspects. It's just a broad overview. So one matching problem is there. So I'll create one table. This is two columns. I can have five of those. This column X. column Y. This is access management. Next is emerging traffic management. Transit priority. Core demand management. Here you have use of intelligent systems, manage traffic flow. Next we have design application control of entry and exit points along a roadway. Okay. Next is to encourage shift from SOV, which is the single occupancy vehicles, to non-SOV modes. And the last one is to increase the speed of buses. So I think you'll find all these aspects discussed in the first module, like the first part of this module. So it's basic definitions of all this, or basic usages of all this. So I think you should be able to answer this. So can anyone answer this? I'll wait for 15 minutes to check what is the answer. Answer first. ADC. So access management is saying design, application, and control of entry and exit points along the roadway. So that's correct. Next is emerging traffic management. So it's actually use of intelligent systems to manage traffic flow. So this is also A. Transit priority or bus priority, whatever you call it, is for increasing the speed of buses. So this will be D. And demand management involves encouraging of shift from SOV to non-SOV. So this is also correct. So this one was pretty straightforward. Okay. So let me now discuss another problem. So which is again true false type. So state true or false. First one is mobility is a primary function of the expressways. Then local roads serve to provide access to abutting properties. Third one is collector, which operates at lower mobility compared to arterial roads. Fourth one is freeways have a higher accessibility as compared to arterial roads. So what could be the solution to this? Okay, so yeah, I think already got an answer in the chat, but thought to take some time. Four is false. Okay, let's check the other ones. Yeah, so actually you have to refer to I think the second part of this module where there is a figure that is shown. So that gives you a picture of this mobility and accessibility. And I think this was also discussed in one of the previous week's content as well with the graph. So mobility is a primary function for expressways, so that will be true. Next is local routes serve to provide access to abutting properties, which is also true. Collected roads operates at lower mobility compared to arterial roads, so that's also true. And freeways have higher accessibility as compared to arterial roads, which is not true, which is false. Because freeways have higher mobility, and mobility and accessibility, their relationship is kind of inversely proportional kind of thing. So if mobility is higher, accessibility is lower, and the other way around as well. So let me write down the answers. So the first one is true. Second one is also true. Third one is fourth one is false. Okay, so this is done. Let's move to the next problem. So let me check which one we can solve now. Yeah, so there is another matching problem. So let's solve that. So here we have so this is depending on the access management strategies that are there in the column X that I'll be writing and the corresponding description given in column Y. You have to match that. So first one, it's non-traversable idiots Next one, separating conflict areas. Third one is promoting intersection hierarchy on these streets. Okay, so the descriptions are right in this column. Safe use and support mobility for all users. Separate driveways from the critical approach areas of intersections. Is appropriate driveways for appropriate transitions from one road classification to another. Yes. Eliminate any conflict points by maintain right turns. Okay, so what could be the answer to this? Okay, let's check the answer if anyone has answered it. VBCA. Okay, that could be the correct answer. Let's check. Yeah, the first one is non-traversable median, so which is eliminating many conflict points by limiting right turns. So there was a figure that was given in the I think slides, so you can refer to that. I think you'll find it around the second part of this module. So I think in the second lecture of this module it was discussed. So this is correct. Second one is separating conflict areas. So my first one is safe use, and okay, that won't be the correct answer. Separate driveways from critical approach areas of intersections. So that's correct. So two will be B. Third one is promoting intersection hierarchy, which is appropriate transitions from one road classification to another. So this is also correct. It will be C. And four is complete streets. It's like safe use and support mobility for all users. So that's correct. So four will be A. So this will be your answer. So yeah, I think then let's move on to the next problem. which is again a true false type problem. So true or false. The first one is poorly spaced and uncoordinated signals hampers the capacity of arterial roads. Next is as the number of signals per mile increases, the travel time increases. Next is for effective coordination of mile. So for expected coordination, half mile or more distance between signals is desirable. Fourth one is increasing the distance between signals improves the traffic flow on major before I finished it, you know the answer. Wow, that's great. Decreasing the distance between signals improves the traffic flow on major arteries. This is from, I think, access management module. So there, you have this concept of locating traffic control sequence to favor through movements. And there were one table, I think, there was one table which gives you a relationship between signals per mile and the increase in travel time. So actually, when the signals per mile, if you increase it, then your travel time increases as well. So this is the second one. Just now I have told that it will be true. Then the first one, which is poorly spaced and uncoordinated signals, hampers the capacity of arterial roads. So that is actually true. And then you have for effective coordination, half mile or more distance between signals is desirable, but actually this half mile or more distance between signals is desirable. That part is true, but that may be too far for effective coordination. So effective coordination requires you to have like kind of lesser distance between signals. So that's why it is false. And then increasing the distance between signals improves traffic flow on major arterials. So that is also true. So that that was also mentioned in the slides that it can reduce congestion as well or improve air quality and heavily traveled corridors as well. So this should be good. Okay, so now let me move to the next problem. Let's see which one I can solve. So, solve. Okay, another true false type question. So state of false. By providing access to adjacent properties on the highway or arterials, stability is it true or false? False. Yeah, the reason is that this accessibility should not be high for this highway or arterials. So the mobility has to be prioritized there, and the local streets needs to be connected to adjacent properties. So this is false. Okay, so now let's solve another problem. So this is, I think, next one that I'll be giving is related to the demand management. So again, it will be true false type questions only. So let's employer based. So this TDM is traffic like demand management makes so the options relatively cheaper than again, so just have some water. So next one is employer based strategies. The provision of free subsidized transit passes. Fifth one is give strategies provide secure workplace parking rights. So that would be the answers to this. employer-based TDM. So this is you'll find probably in the third uh, lecture of this module. So there the demand management have been discussed in detail, and employer-based traffic demand management is one of them, and it is related to that only, this question. Okay, so let's see if there is any answer. 245 is true, 3 is false. So let's check. See, 3 is false. So the first one is employer-based TDM makes non-SOV options relatively cheaper. So that's true. So you don't want to encourage single occupancy vehicles. So that's why this part is true. Then it offers higher parking rates to carpools and van pools. That's not true. That's actually false. So yeah, that's correct. Then this PDM strategies have the provision of free or subsidized transit buses. So that is also true. And it provides secure workplace parking for bikes. That is also true. Okay, so this was correct. So now let's move on to another set of this true false type questions. So this is related to again this demand management only, but there is another concept called flexible scheduling. So this is state true or false with respect to flexible scheduling. First one is, so this flexible scheduling increase number of weekly commute trips. Next is shift work trips from non-peak hour to peak hour. Next is work from home. That is encouraged. And the third one is increase in number of work days per. Okay. So again, it's from that demand management module only. So I think you should be able to answer this. there any answer to this? Option 3 is true. Yeah. So flexible scheduling means what, come on? So this is true. Increased number of weekly commute trips, that is false. That is not at all encouraged. Shift work trips from non-peak hour to peak hours. So it's actually opposite. It shifts from peak to non-peak hours. So this is false. An increase in number of work days per week, which is also false. It actually decreases, like encourages decreasing the number of work days per week. So that's correct. So let's solve another problem. Check which one I can solve. Okay, so again it's true false type questions, and I think you will find it in the next module, or the next part of this module, which is this bus priorities. But let's see what exactly this is. So state true or false with respect to splitting of phases for passive bus priority measure. Let's write this down one by one. This is optimal cycle length remains same. Next is increases the capacity of the intersection. Third one reduces the total startup lost time during a cycle. Finally, reduces the waiting time during red interval. With answer to this. So this comes under the signal-based bus priority treatment, and within that you have this passive bus priority treatment. And there you have a discussion on splitting of phases. So this splitting and kind of repeating of phases may benefit buses because the waiting time at red generally decreases. So that's one of the answers that I have given you. And there are like other aspects like about optimal cycle length, when whether it increases the capacity of the intersection or not, or reduce total startup loss time during the cycle, those kind of things. So is there any answer to this? Option A and D are good. Explain signal-based priority treatment, passive bus priorities, all delay timing. Okay, check. Yeah, and signal-based bus priority treatment. So what we are doing is we're adjusting this traffic signals at intersections, and the passive priority treatment. So there are different, I think, types. One is passive, then the active, some real-time priorities, and so on. So in passive priority, the Objective is to maximize the green time for the bus route, and this is effective in cases where bus dwell time is kind of predictable. And this is mentioned that the dwell time is the boarding and alighting time of passengers, so on. So there are different ways of doing it. One, I think, is adjustment of cycle lengths, then splitting of phases that we have talked about. So expense of the nearest set was priority, small delay time. Okay. The delay time is actually, I think, related to the cycle lengths, and longer cycle length means you definitely having more red time, and that can increase delays as well. So that's why I think shorter cycle lengths are preferred. So it's like early repetition of phases and shorter duration of red phase means reduction of delay time. So it's related to that delay thing. And if you look at, so it's again related to the splitting of phases thing. So if you can like reduce the waiting time at red, if you reduce the red intervals, so in that case, what happens is that your delays also decrease in that case. So that's the concept here in splitting of phases. So the answer here is correct. So optimal cycle length is remains the same. Increases the capacity of the intersection, that is not true. And then you have, so it might, so this total startup loss time during a cycle. So this, if you have more now, if you are doing this splitting of phases, that means individually you might be having, say, more red times. So, yeah, plus priority measure fixed or determined. Okay. Can you unmute and ask? I'm not getting what you're talking about. What is your exact question? Yeah, so there could be decrease in capacity of intersections. So let's complete this. So this will be false again. It can be increasing the startup loss time during the cycle and reduces the waiting time during the red interval. So that's true. So there are other methods within this signal based bus priority treatments. I think adjustment of phase lengths and area-wide timing plans, bypass metered signals, and so on. Within the active priority, I think it's there are concepts about green extension, red truncation, and those things. Real time is Something, okay, so I think you asked about real time, is it? Yeah, so real time is actually, it's not that used much, and it's uh, requires, I think, some equipments and so on. It ends up having some measures like passenger delay, vehicle emissions, and those things. And preemption is like emergency vehicles applied for those mainly. So that's the idea. Okay. Yeah, I think if you go back to the lecture and probably will get the idea more about the signal-based bus priority treatments. Maybe I'll move to the next question now. So there is one on this passive active priorities and real time. Just now I have discussed, but let's solve this. It's a matching type problem again. This is column X. So this is real time priority, and fourth one is this preemption. Here we have just the traffic signal after detecting the bus arrival. It's commonly applied for emergency vehicles. Timed response to traffic signals is buses as well as non-priority vehicles are detected. Okay, so what would be the answer to this? So it's kind of tells you the adjustments like or the differences between passive and active priority. So I think we mentioned that pre-time thing here as well. This Discuss assignment related questions. Yeah, I'll discuss. I'm discussing, and also I'll discuss. Okay, what is the function of SOD single occupant vehicles? Okay, single occupant vehicles means it's that one. Like if you're taking, say, your own personal cars, you are the only occupant for that, right? So that's what single occupant is. Discuss assignment related questions. Okay. Yeah, I'm discussing the content, right? I'm not solving assignment problems directly. Okay, so what would be the answer to this? Yeah, this is correct. This is also correct. Active priority is no. Oh, this is A sub. Adjust the traffic signal after detecting the bus arrival. Okay, that's active priority. Phase real-time priority, which is buses as well as non-priority vehicles are detected, and preemption is commonly applied for emergency vehicles. Okay, so that's fine. Let's solve another of this. This is column X. Main extension. So this is again related to active measures or active priority translation. This is special phase, and the fourth one is phase separation. When the bus needs to perform a turning maneuver, adopted where the bus reaches the intersection during amber phase. C is adopted when the bus reaches the intersection approach during the red phase. D is non-priority phases. So what would be the answer to this? So green extension is done when you want the bus to pass that intersection without any like hindrance or so. So this would be the okay. Is there any correct answer? It is B, C, A, D. So yeah, B will be correct for this because otherwise the bus will be reaching during the amber phase. Then this red tech truncation, it's reduces the like green phase for the other movements of the bus phases. So this is applied when the bus reaches the intersection approach during the red phase. So this will be C. And then there are special phase, which is when bus needs to perform a turning maneuver, and phase separation is non-priority phases are stripped. So that's correct answer. Okay, so let's move on to the next question. So in the assignment, you will also find similar type of questions, not exactly the same ones, right? So, like I cannot give you the answers directly, so it's not like I have to solve those. Okay, so let's solve another question then. This is about uh, facility-based post priority. So state true or false. Respect to post priority measures. This is contrast to first lanes are typically divided on two-way streets. Next is intermittent bus lane refers to lane that can change its status from regular lane to bus lane. Exclusive bus lanes are single lane operating in one direction during one time period, then reversed to operate opposite direction. Both runners. A shared bus lane is a lane which buses share with other special vehicles such as high occupancy vehicles, bicycles. Okay. So again, it's very straightforward. So this facility-based bus priority treatments have been discussed. So this contraflow bus lanes are typically provided on one-way streets, short one-way streets, not two-way streets. So this will be false. Then intermittent bus lane. So this refers to a lane that can change its status from regular lane to bus lane. So that's correct. Next is exclusive bus lanes. So for this, here it's written that a single lane operating in one direction during one time period, then reverse. So that's not the correct answer because I think it's the definition of another type of bus lane. It's not this exclusive bus lanes. So that is, I think, reversible bus lane. So this is false. And a shared bus lane is a lane which buses share with other special types of vehicles like high occupancy vehicles and bicycles. So that's good. Yes, indeed. Yeah. Okay, so let's solve another problem. This is again state true or false. This is Q jump lane signal or time based bus priority treatment. This is again straightforward because it is false because it is facility based bus priority treatment. That's straightforward. Let's see what's left. Okay. So let's take few more uh, true or false type of questions. So state true or false with respect to adaptive RAM metering. First one is dynamically control the rate of vehicles entering an interrupted facility. Next is RAM metering signals contain red, amber, lights. Then allows for efficient use of existing capacity of the facility. The last one is traffic signals are deployed only on freeway. Okay, so this is again from the slides only. So adaptive ramp metering has been discussed. The first one is actually false because it should be in an uninterrupted facility, not an interrupted facility. Then you have metering contains this red, amber and green light. So that's not true because there is no amber present. Allows for efficient use of existing capacity. So that's true. And traffic signals are deployed on freeways. Actually, no, there is no signal on the freeways on the other way around. So this is false. Yeah. There's one more thing question. Then I'll ask you about the assignment. Let's check what's left. Okay, there is a matching type problem. So this is with respect to, I think, this different aspects like dynamic pricing, this adaptive traffic signal control, and so on. So it's like the definitions are given in the other column. This is column X and column Y. So the first one is dynamically priced parking. Two is adaptive traffic signal control. Three is dynamic wayfinding, sorry. And fourth is dynamic pricing. Here it's to efficiently balance parking supply and demand. Is optimizes delay, queue length, etc. at the intersection. Next one is utilizes tools that dynamically change in response to congestion. And E is utilizes the time spent searching for parking. So what would be the answer to this? The first one is straightforward because it is, I think, to efficiently balance A, B, D, C, is it? First one is dynamically priced parking to efficiently balance parking supply and demand. Okay. Adaptive, okay, I'll just write. And adaptive traffic signal control. Okay, so it's the minimizes the time spent searching for parking. No, it shouldn't be D, right? Or A, B. Okay. Yeah, it optimizes delay queue length at the intersection, so that's correct. The three is dynamic wayfinding, which is about this to efficient, not this one. It's minimizes the time spent searching for parking. So that's D. And fourth one is dynamic pricing, which is utilizes tool that dynamically change in response to congestion. So that's good. This is Okay, now about the assignment. So I think it's very simple, right? You can answer all the 16 questions, shouldn't be any difficulty. Do you want me to discuss any specific question or did you find any problem difficult in the assignment? Then I'll take a look at it. Let's discuss. This is the assignment. First one is in urban area. Okay, it's very basic stuff from the first one in traditional area. Okay, it's very simple about freeways and roads. Again, mobilities and accessibility. This I have also discussed. Complete streets and everything. Those portions are I think also being discussed. For access management, yeah, yeah, I think it is directly from the slides. Chicken awareness not a collective state. So, okay. Yeah, I think I discussed a similar question to this as well. So I think this one also is similar to what I discussed. Employer-based ETL. Congestion pricing is something that was discussed in the lectures, so I think that should be easy. Yes. Here also to get another problem. Okay, passive bus priority measures. Okay, this is again direct. Yeah, this is again about those passive control. Simple. This is about bus priority measures. This is tolling. And this, I think some of them have been discussed as well. Yeah, one of them I think is there in the matching as well. It's pretty simple. I think this is a few nine. Check the following. So, to respect to congestion pricing, okay, same amount of toll is charged during peak and off-peak hours. What's difficult in this? I want to ask you, why can't you answer this? Because this is directly from the slide. So what's there to discuss? Can you tell me whether A is true or false? Like if you're asking this question to me, I think you haven't gone through the lectures at all. Because it's the basic concept of congestion pricing. I think one issue could be is that here maybe R through is later written, so you may think that there could be multiple answers to this, but maybe if you go through the slides, you'll probably find that only one of them is true. But anyway, whatever answer you're getting, just mark that. Other than that, cannot do anything else about it. B is true. Intends to reduce transit trips. Well, that's not at all true. Congestion pricing is like about you disincentivize something or you increase tolls so that people move from their personal vehicles to transit vehicles. So it's like transit trips, you want to like increase it so that though people don't do personal mobility and everything have to reduce. Because that's why this so suppose you have a bus which can fit 40 people and now you think that uh, I want to reduce transit trips. Means you're reducing buses. So that means those 40 people now are traveling in their personal car. So the space that is required to in the road to accommodate all those 40 cars, it's much higher than one bus, right? So congestion pricing doesn't at all entertain that. So it's basic stuff, right? How can B be true? It's false. Look, I can give you all the answers to this assignment problem. You will get full marks and everything. But if you are not able to answer this kind of questions, which is direct from the lectures, then how would you like do it in the exam? So it's better if people go for carpooling, right? So because more people are traveling together in that case. Okay, anything else? I see. Okay, nine. Okay, this is Q1. Okay. Wait, if you're asking me about question one, then you haven't gone through the first few slides itself. It's the most basic one, right? It's the first lecture that have been discussed. Okay, in the urban area, the morning and evening rush hours lead to increase in congestion. Rural areas may be susceptible to congestion due to recreational and seasonal activities, special events, festivals, limited options of travel in rural areas may lead to increase in delays. So what do you think? What would be the answer to this? Like, why are you confirming this from me? Because it's already there in the lectures and slides. Just go read slide 13 and 14. I think it's on application in urban, suburban, and rural areas. Those slides, and you will get the answer. So, what do you think? Which one is false? Yes, false. Okay. Limited options of travel in rural areas may lead to increase in delays. So you're saying that there won't be any delays because there are limited options. Suppose I have only one road in rural area that is available for everyone. Everyone comes to that road, okay? So now everyone is stuck on that road. So what do you think? There will be an increase in delay or you're decreasing your delay? Because you don't have any other option to switch to another route from there. Like, can you explain to me the logic of why you are thinking C is true? Sorry, C is false. Like, I'm asking you now, why do you think C is false? Like, answer it yourself. Like, think about it and then answer because I'm not giving you the solution. Because that's not this session is meant for. It's solving and not solving the CS assignment questions. Like, go back to that lecture one of this week and listen to that part again and then think of it yourself that what should be the answer to this question. Okay, any more doubts? Like, should not be trivial doubts, should be something major. Last week's assignment. Okay, this question was it. Let me check. Wow, you are asking this also? This was also discussed last week already, right? Uh, is there any issue with this? Because a similar problem is already solved in that class. Okay, accepted answer is D. Okay, let me just directly open the solution and show it to you. Like what's difficult to understand, I don't get it. Uh, Even the solution has been posted, right? Okay, so the leading vehicle and following vehicles are traveling at the speed of 16 meters per second, and speed spaces headway 25 meters at t equals 0. The vehicle of deceleration is done for 2 seconds. Okay, sensitivity coefficient alpha is given, delta t everything is been given. Okay, so it's x x double dot x1 double dot is the initial acceleration. So since it's a deceleration at t equals to 0, you will be taking this as a negative sign. So that's why it's -2. Speed is given initially. For the leading vehicle is 16. Space headway is given. So if the follower is at 0, you are at 25. So that's the spacing. And then the acceleration of the following vehicle, it's initially it's moving with a constant speed. So there is nothing that's happening here. This x2 dot is given as 60. So you can find x1 dot minus x2 dot, which is required, I think, in that question, and x1 minus x2 as well. So you have to find what is the speed of linked vehicle at t equals to 2. So it's this value that you need. For that, you have to do this updates. Now this update interval is given as 0.5 seconds, but the reaction time is 1 second. So up to this 1 second, it's very simple, straightforward updations. Like this is will be same. This velocity is v plus u plus 80. That formula is there. So this is 16 plus minus of 2 multiplied by 0.5, which is the interval. That's why you get 15. Then this is the S equals ut plus half at square formula that gives you this. Similarly, you do the updates for this following vehicle as well. So you'll get those. Till this 1 second, this kind of updates will be there, right? Now after that, once this reaction time and everything comes into picture, now you will apply this to the follower model, right? So this delta t is 1. Now your t, so when you will be updating it, say for 1.5, you will be taking all these values that you have updated at 0.5. So your t is 0.5 here. So yeah, even I think for t equals to 0, if you take, you can update it for t plus 0 plus 1, which is 1 second. So this updation will come here as well, but I think it will end up being as 0. So here you will get some values updated according to this equation, and based on that, again the formula is the same. V equals u plus 80 and s equals ut plus half 80 square. After that, similarly, we'll update it here, and that's how we reach to this value. So this, I solved a similar problem last week. If you have attended that, you will get it, and this table was populated. Is there any specific issue to this? Because like calculations or anything? I don't think that's an issue because no one raised this point, I guess. Okay, we're joined late. Okay. So that's the idea. It's again simple, right? Let me check. So, which part you don't understand? Is it clear to you how to do this? Possible, I'll open that. Okay. This is the last week's example. So here, Okay, so it's the similar problem, but here at t equals to 0, the lead vehicle accelerates with 1.2 meter per second square for 1 second, that is given. And all the data otherwise I think are same. So at t equals to 0, so your acceleration is given, that's 1.2 meter per second square. Speed is 16. Position is given, 25 is the spacing, and then this is 0, this is 16, this is 0. These are problem data at t equals 0. At t equals zero point 0.5, this is same because it accelerates for 1 second, and this is u plus a times t. This gives you this update. Then this is s, means whatever you had, plus this ut. This is u was 16 times t plus half of a t squared. So that gives you this update. Then this is 0. This is speed of the following vehicle will remain as same. Position you have to update in terms of s equals ut plus half a t squared. A is 0 in this case for the following vehicle. Similarly, you can calculate these two columns as well. At t equals to 1, again you have to do similar updates, but now your acceleration becomes 0 here in this problem because you are done accelerating for 1 second. And again you do the similar updates here, and here also you do the similar updates for the following vehicle. Now, after that, at 1.5 when you update, since the update interval is, so you had that GM equation using which you have to find the acceleration of the following vehicle. So here, I think the formula is alpha times, it's written here, this is the formula. So this is xn dot minus xn plus 1 dot. So at t equals to 0, both of them are 16 meter per second. So this will vanish and this part will be 0. So that will be at 0 plus 1, which is delta t here. So at t equals to 1, the acceleration of the following vehicle will also remain as 0. But after that, the speed difference is 0.6. So because of that, your acceleration value will be changed, and that you will calculate through that formula. And other than that, all the other calculations are same, those two equations and this GM equation. And then you will do similar updates using that GM equation here, and the v equals u plus at here, and s equals half ut plus half at square. So that's the idea. I think you should get it. If you go back. Okay. So okay. So yeah, I think you should be able to understand. Anything else that you have a doubt? This assignment really. Like actually you shouldn't be having doubts if you go through the lectures carefully, because this is due tomorrow, right? This assignment. I think by this time you should be able to solve all this and could have submitted. Anything else? I think there is one confusion. So Yeah, so the language of this problem, I think it's a bit confusing. Rain extension may be applicable when bus reaches the stop during amber or red phase, but actually it should be like when the bus otherwise would have reached that stop during amber or red phase. But I think that's the meaning that should have been conveyed there. So it was a bit confusing, I felt. Other than that, I think it's easy. Yeah, that is true. But actually, the bus doesn't reach amber or during amber or red phase if you include green extension, because once you do the green extension, the bus passes through that intersection. There is no amber or red phase. So it should have been written as when the bus otherwise would reach the stop during amber or red phase. So, so what do you think the answer to this would? If you have read the lectures, you would be able to understand. Considering variable tolling increase in toll during the red phase must be large enough to so users while remaining acceptable for users unable to return earlier or so I'm asking you what is the answer to this 40? 40? Okay, so that means you haven't solved the assignment yet. I was just checking. Anything else you want to discuss? Like this assignment is so simple that you should all be able to get full marks here. There is no numericals, there is no chance of having mistakes. Yeah, that was true. Yeah, that's correct. This SOV thing is clear to everyone. Single occupancy vehicular trips. Someone was asking. It was discussed in the lectures as well. Should be easy. Which one is B? Uh, which question are you answering? 6, you're saying B. Okay. Look again. You haven't read the things entirely and listened to the lectures properly. You're making mistakes like this. What do you think? Option A is correct or not? wouldn't expect like people to make such mistakes. So what is non-SOV trips? What do you mean by non-SOV? Have you understood this? This non-single occupancy vehicles means buses, and single occupancy vehicles means private car. So what do you think? Through demand management, should we shift people from buses to their private cars? It's a, Even if you haven't read, it's a basic common sense type question. You are not able to answer. A true. A true or A is the correct answer. True means in what sense? Okay, think about it and answer it tomorrow. Let me test another one. What do you think the answer to 5 would be? Strategies that increase overall system efficiency and encourage commercial plants and developers. Yes. Yeah, so it was SOV to non-SOV. Here it's written as non-SOV to SOV. The ordering is different, right? So you have to check for that. So what you have written is that it encourages the shift from SOV to non-SOV. It's not the other way around. So that means this statement is incorrect, right? A is not true. It's actually the statement is incorrect, but the answer would be it's not a characteristic. So A is the answer. Are you still confused? Like read the statements properly. It's like I think you'll be able to get it. So what would be the answer to 5? Then it is directly from the slide. So yeah, go back and I think I'd suggest. I don't know whether you are even listening to the lectures or not. So listen to those lectures carefully. I know it's long, 4 5 hours per week. But if you're not listening and simply coming to this class and expecting I'll give you all the answers, that's not going to happen. Yeah, you have to put in efforts and see what would be the answers to this assignment. Okay, anything else? Any other doubts? Anything? Like I went through this assignment and I felt there are no questions that are wrong or anything, so I'll be able to answer all this. There shouldn't be any issues, and everything is included in the slides. Okay, anything else? Else, I think it's almost 9. I'll close the session if you don't have any more comments. Anything else, or you are free to leave this session? I'll close the session. But yeah, do go through the lectures. I'm disappointed by looking at this condition. Five. Oh, the one that I asked, you are having a doubt. Okay. Okay. So I can tell you that it's there on the access management slides only. Around so 30, between slides 30 to 40, you will find the answer. What else? Okay. So there is a figure that is there in the slides. There it's showing exactly whether driveways should be located inside the functional area or intersections or outside. So look at the figure and try to answer. I'm not giving the direct answer. Then higher traffic speed requires lesser driveway separation. So this is also discussed in the lecture. So sir clearly mentioned it in his lecture. I think if we are just skimming through the slides and not listening to the lectures, you will never get the answer. Corner clearance is something which is important and you need to have it. That's what I'll tell, but I'm not giving you the any answer. And yeah, so the large number of drivers decrease the potential conflicts on the roads. Actually, conflicts are directly related to the number of drivers you will have. So the more you have, the more conflicts potential will be there. Yeah, so by listening to it, you should be able to answer what is the correct number. But listen to the access management lecture. Otherwise, you won't be able to answer this. And requires it. So you're saying D is correct. Wow. Still not able to answer it. Okay. I, here it's written as true. Here you have written higher traffic speed requires greater driver separation. There it was written as greater. Here is written as lesser. Yeah, it's fine. But why you are writing D as the correct one? I don't know. Like listen to the lectures and then answer. Otherwise, you will always make mistakes in every question that I'm looking at it. By the way, how did you answer the questions that I wrote today? And you answered those in like microseconds, even before I ended up like writing it. I think you already had those solutions from somewhere. That's why you answered those, and you were not able to answer this ones. Adequate convert clearance to rely capability. So yeah, so it's written here. Okay, so why are you writing it as D if you have just written the statement that is here, right? Okay, by seeing this statement that you have just written, answer it. What would be the answer? Why D? Why you have written it as D? Okay, anyway, it's 9 p.m. I'll close the session for now. So yeah, go through the lectures first. That should be your priority, and then answer this. Even if you if you are not able to answer those assignments, you'll be in trouble in the exam. Okay, so I'll close this session. Okay, typing mistake. Yeah, so that these things you have to be careful. There shouldn't be any typing errors or anything that you'll be seeing. Okay, so I'll close this session. See you all next week. I'll stop sharing your screen. Yeah, you're free to leave the meeting.